Hello and welcome to Mrs. Law's class. In this lesson, we're going to take a look at expressions and equations by looking at patterns. So an expression is a mathematical statement made up of numbers and or variables, and they're connected by operations. Now for expressions, they do not contain an equal sign. So for example, an expression could be 12x plus 5. Now we contrast that with an equation. So an equation is a mathematical statement made up of two expressions that are equal. So because they're equal, it does have an equal sign. So for example, using the same expression I wrote on the left, we could write y equals 12x plus 5. So notice that the expression doesn't have an equal sign, whereas the equation does. So after spotting a pattern to a sequence of numbers, it is often helpful to write an equation to describe the pattern, so then we can use that equation to find any number in the pattern. Now in this unit, we're going to focus on finding patterns and describing them numerically, graphically, verbally, and also algebraically. We're going to use this example here to learn some definitions and also to create a table of values. So Luke wants to earn money this fall raking leaves. He will get paid $9 per hour. So what two quantities are being compared in this problem? Well, he wants to earn some money and he needs to figure out how many hours he needs to work. So the two quantities are amount earned stated right here. And the second thing is the number of hours worked. Stated right here. So which quantity is the independent variable and which is the dependent variable? Now the independent variable is the variable whose value is not dependent on the other variable. So in our case, in our example, that would be the number of hours worked. So the number of hours worked does not depend on the amount that he earns. The second thing is the dependent variable. So this is the variable whose value depends on the independent variable. So in our example, that would be the amount earned. And that is because the amount earned depends on how much time he works, or the number of hours he works. So when trying to figure out which quantity is the independent and which is the dependent variable, complete the following sentence by putting in the words from the question. So you want to say the blank depends on the blank. The first blank is the dependent and the second blank is the independent variable. So in our example, we would say that the amount earned depends on the number of hours. All right, next we're going to create a table of values to model the first 5 hours of work. So we're going to place our independent variable, which is our number of hours, in our first column. And then the dependent variable, the amount earned, goes in the second column. All right, so we have the number of hours worked. We'll start at 1, and then we'll go to 5. So to figure out the amount earned, in 1 hour, he would earn $9. So actually, we should put a dollar symbol to indicate this is dollars. In 2 hours, we're going to earn 18 because we add another 9. And we keep adding 9. He now earns $27 in 3 hours, $36, and then eventually $45 in 5 hours. All right, our next part is to write an expression to represent the amount Luke earns per hour. Use H to represent the number of hours worked. Okay, so we can see that he earns $9 every hour. So therefore, our expression would be 9 times H, or we can just say 9H. Now that we have the expression, I want to write an equation to represent the amount Luke will earn. Write your equation using A to represent the amount earned. Now, I have a note here. So whenever the independent variable, which is the numbers in the first column, increases by 1, and you can see that's what's happening over here. So it keeps increasing by 1. We go 1, and then we add 1 to get 2. We add 1 to get 3, and so on. Adding 1 to get 4, and adding 1 to get 5. So whenever the independent variable increases by 1, you can use this strategy to find the equation. So first, find the difference in the dependent variable. Okay, so the dependent variable, remember, is our second column. Now, no matter where we subtract, we will find the difference is always the same. So we can take 18 minus 9 from our table, or we can take 27 minus 18, or we can take 36 minus 27, or we can even take 45 minus 36. So if you take any two consecutive numbers and we subtract them, we will always get 9. Now we can see that the 9 is always constant. Now if the number that the dependent variable increases is constant, we're going to use this number to multiply by the independent variable. Now the independent variable in our case is H. And I didn't put this up here, so I'm going to go back to my table and say that this is H. So we can now write 9H, which we had before. Okay, that is our expression. Now we're going to work backwards to find the value of the dependent variable when the independent variable is equal to 0. This is the number that is added to the previous expression, because you want to figure out how much he gets paid even when he works 0 hours. Now in this case, if I do keep continuing my table but going backwards, so we're going to go here, this would be subtracting 1, we would have 0 hours. Here we would subtract 9, and we would then end up with also $0. So that means that our expression is going to be A for our amount equals 9H, and then we're going to add this number that we get when he does work 0 hours, and that happens also to be 0. So this is our equation. We don't really need the 0, so we can then rewrite this equation as A equals 9 times H. Now that we have this equation, we can now determine how much Luke will earn given any number of hours. So this first one here is how much will he earn if he rakes leaves for 12 hours in 1 week. So our amount is equal to 9 times 12, and that will be $108. We can also use the equation to determine how many hours Luke needs to rake. So let's say he wants to earn $72. So 72 is our amount. We're going to place that for A. And 72 equals 9 times H. So this time we're looking for H. Divide both sides by 9. And then H is equal to 8 hours. So that means that he needs to rake for 8 hours to earn $72. Let's take a look at another example. All right, here we have a banquet hall. It has small square tables that seat one person on each side. The tables can be pushed together to form longer tables as shown. So sketch the next two table arrangements in the pattern. So we have 1 table, 2 tables, 3 tables. So our next one will be 4 tables. And we can place one person on each side of the tables. And also in the ends. And in the next pattern, we will have 5 tables. And again, we can place one person on each side of the table and also on the ends. So what stays the same in each table arrangement? Well, we can say that the first table stays the same, which has the original 4 people. Okay. And the second question, what changes are made in each table arrangement? So we can see that every time we add a table, we don't actually add 3 people. We can actually move the end table down, and then we're going to place a table inside. So like so. And then we're going to add 2 people. So for every new table added, two more people are added. So looking at the situation, what are the independent and the dependent variables? All right, so I've set up the sentence. So we can see that the number of people that are sitting or we can just say, sorry, the number of people depends on the number of tables. So now that we know that, we can set up our table of values. So let's create a table of values to show the first 5 tables. So number of tables, and this will be our number of people in the second column. So we're going to have 1, 2, 3, 4, and 5 tables. And then in one table, we can see that we start off with 4 people. And then every time we add a table, we're going to add 2 people. So plus 2, plus 2, plus 2, and then plus 2. All right, so let's finish off by writing an equation using the variable t for the number of tables. So I'll put that also in my chart. And p for the number of people in this problem. All right, so if you recall, I had recommended that we first take a look at what our constant number that is being added, and we can see that is always going to be 2. So we can say that the number of people, p, is equal to 2 times t. So we increase by 2 each time. However, when I go back and notice that I keep on increasing by 1, if I go back 1 and I subtract 1, I get 0 tables. So when there are 0 tables, I'm going to go back with the number of people as well. I'm going to subtract 2. And when I subtract 2, I will see that we get 4 minus 2, which means that there will be 2 people. And this number 2 is what we add to the equation at the back here. So you have 2t plus 2. And this 2 is important because that is the number if there were 0 tables. Whereas this number 2 is the increase in people for each table. And that's how we write the equation.